Good day, students. Today, we want to consider a topic titled Arrangements of Cells and Resistors when cells are arranged in series. The total EMF equals to the sum of the individual EMFs. That is, E equals to E1 plus E2 plus E3. For example, when you have three cells joined together to give us higher voltage, and let's say 1.5 volts battery, 1.5 times 3, that's 4.5 volts. It gives us increase in the current flow in the circuit. And which if it is one battery, if it is one cell, it's referred to as cell. But when it's more than one cell, you have battery. Okay, now when they are connected in parallel, when cells are connected in parallel, they have the same output of current flow or voltage flow. Let's see. The total EMF of the cells arranged in series is equal to the sum of the individual EMF of the cell, of each cell, individual EMF of each cell. E equals to E1 plus E2 plus E3. The internal resistance R of the series arrangement is the sum of the internal resistance of each cell. R equals to R1 plus R2 plus R3. You can see it. Each cell has its own internal resistance. When they are connected in series, you just add them together. You can see when you have the first cell is 1.5 volts, second cell 1.5 volts, third cell is 1.5 volts. Just add them together directly. Now let's see parallel connections of cell. Now in a parallel arrangement of cells, all the positive terminals are joined to one point. All the positive terminal, the long line is the positive terminal, while the short one is negative. Okay, positive, negative, positive, negative, positive, negative. When you are connecting battery together, you connect the negative to the positive. Is on the cell. Positive, negative to the positive, negative to the positive, like that, so that because unlike poles attract, there will be current flow when you connect them like that. Okay, now so you can see under parallel connection, all the positive terminals are connected to one point, all the negative are connected to one point. Because of that, they have this equal output. Now what is coming out now, it now be 1.5 volts. Is that okay? Because they are connected in parallel. But here it will be added together to give us 4.5 volts. Okay, and all the negative terminals are joined to another point B. You can see there, joined to another point B. So I join to another point A. If each cell has an EMF E, the net EMF of the parallel arrangement is also E, that of a single cell. Arrangement of resistors. Resistors in series. When resistors are connected in series, the same current flows through. But as it's coming, there will be voltage drop here. V1 equals to IR1. Because the same current that flows here, when it comes here, the current comes here, I is also I, current here is IR1. When it gets to this place, say current enters, because they're in series, IR2. When it gets here, IR3. Now your V, which is equal to IR, Ohm's law, is that okay? Ohm's law. V equals to V1 plus V2 plus V3. Now V equals IR, because the voltage that is coming in is I times resistance of the wire. Is that okay? I times resistance of the wire. Now when it gets here, there will be voltage drop here, which is IR1 plus IR2 plus IR3. currents factorize out, it will cancel each other. R equals R1 plus R2 plus R3. You can see that, for example, when you are adding them together, the ohms, just with direct addition. Okay, under series connections of the resistor, always know that you add them directly. Okay, the same current flows but different voltage drops. Now, when it gets to resistors in parallel, current divide, you can see it, I equals to I1 plus I2 plus I3. In Ohm's law, V equals to IR, I equals V over R. Now, because we want to know the equivalent resistance in parallel, we have I equals V over R. Now, V over R equals, because that V, I equals to V over R, the voltage that pass across the three resistors in parallel, which is V, over the resistors of the equivalent of all of them, because as it's coming out, they have the common point at which current enter and it goes out. Is that okay? It's having equal voltage and their equal resistance will be taken into consideration. Okay, that's why you have I equals V over R of the wire, which is entering. Or when it gets to this place, gets inside, you have different voltage drops because current divides. Also, you have V over R1 plus V over R2 plus V over R3. You factorize the V out. When you factorize it out, V cancel V, you are left with 1 over R1 plus 1 over R2 plus 1 over R3. Now 1 over R equals 1 over R1 plus 1 over R2 plus 1 over R3. Under parallel connection, we have different currents that because it divides, but we have the same voltage across the connection because they are connected in parallel. Take note, under series connection, the same current flows but different voltage drop. Also in series, in parallel, you have different current but the same voltage. That's why you see it V over R1 plus V over R2 plus V over R3. Is that okay? Same voltage is being considered across the parallel but different currents. Is that taken? Now you now have in parallel 1 over R equals 1 over R1 plus 1 over R2 plus 1 over R3. That's the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.